So what's up to anyone just joining in? Let's just see here. All right, let's see. Let's get this fixed up. So we got a few people here. So hello to anyone just joining. I'm going to wait for the chat to get going here so I can, teach whatever topics people want to learn. So hello to anybody just joining in. And welcome to week 5. So very nice. I'm very excited to be getting this going here. Thank you for anyone coming out to support the live stream. So hopefully we could take a look at some good math questions today. All right, let me just check the actual stream here. All right, it says we have a few people on. So I can, let's see. Just messing around with this new overlay here. So now I could display comments. So I did some behind the scenes work to make the chat portion a little bit more engaging. So, all right. But what I will do is, unless someone says something new in the chat, I'm going to switch over to the math view. And I will wait for the first topic to pop in. So let me pop the chat back in here. So I will shrink this and restore the chat. And now from here, let's switch back over to the math view. So there we are. And let me make this full screen so we get the full effect. Perfect. So I will just wait for the chat to light up with topics, and then we'll get going here. So anyone who's here, for one, hello. And if you got anything specific you want to see, if you're one of the first people here, you get first dibs on whatever it is you like to learn. So we've got, all right, 3 concurrent viewers. So whatever topics you want to see, just type them in the chat. And yeah, we'll take a look. I could, of course, always pull up my own questions here. But yeah, I prefer to stick to the topics that people specifically want to see. All right, now we have 6 views. So let me, I'm going to open up the practice questions that I usually draw from. So let's see here. If we look at lessons, all right, get that back going. All right, perfect. So we are then ready to go. So anybody in the chat, feel free to type in what would you like to see covered here. Otherwise, I can just pull up random questions here. And I usually start with calculus if no one has a request. So we have 4 people here. Very nice. I'm hoping the chat is active here, unless people are just quiet right now, which is fine. Oh, hello. All right, so Xiaolong, you're the first one to say hi, so hello. If there's anything specific you'd like to see, by all means, you could get us going here. Eventually, I have to share this. I have to get the word out that there's weekly calculus help on. I got to maybe try in the Reddit community, because there's a AP student subreddit that I think there's like, a few thousand followers that even if I get like 5 new people, like every new person we get is great. So is there anything specific we would like to see? I always like it when the people here let us know, or let me know what it is they'd like to see. So, Xiaolong, I know you're here, but if there's anything specific, I mean, I could just pick out random limits and stuff like that, just to get it rolling here. So, yeah, I mean, I could always just pull up a random limit, maybe a limit of a piecewise function to get started, unless there's something specific we'd like to see. Yeah, I guess we could look at a piecewise function. Okay, what's the question? What topic? So at Richard, what topic would you like to see covered? So you just type it away, and I will put something together. Oh, sorry, Nanakun. Discrete time dynamical systems and cobwebbing. So when I say high school, college math help, my cap right now is calculus 2. Differentiability system of equations I can do. So Nanakun, yeah, I could direct you towards. I could give a shout out to the Math Sorcerer. If you don't already know about Math Sorcerer's channel, I'm not sure if he has dynamical systems in there, but he's like all about like most of the college level math you'll look at. They might have something on dynamical systems. Eventually though, at Nanakun, I do want to brush up, and I want to relearn calculus 3, differential equations, linear algebra. Like those are the core classes that most, if you're not a math major, but like engineers will have to take. So to make it more, what's it called? Far reaching. So I just apologize, but I'm not going to pretend, and because you'll be able to tell that I didn't even take dynamical systems. I took differential equations. There was something I believe called like chaos theory. It's a very interesting topic in math though, for sure. So very cool that you're taking that class, but sorry that I will not be able to answer questions on that one. But thank you anyway for, stopping by. And if you want to hang out, you're always welcome to hang out as well. All right, so let's see. Differentiability. All right, so something like this. So if we had, let's say f of x equals, and we have a piecewise function. It's usually a piecewise function that you're going to deal with this with. And then we have something like ax squared plus bx for x greater than or equal to 1. So if the goal is, so let's what's the actual question? Well, for one, a and b are constants. So a and b are constants. Okay, and then the goal here is, what's the value of a and b that will make the function continuous and differentiable? So just in case someone's just signing in after the fact, fine. A and b. So f of x is continuous and differentiable. All right, and is it going to fit? It is. All right, perfect. So for a question like this, what you want to do is, first you want to establish continuity. Now, if it's multiple choice, remember, notation doesn't matter. And just know these are usually multiple choice questions. But if I had to practice nice notation, I would want to find the limit as x approaches 1. And to do that, if I take the limit as x approaches 1, I'm going to check on the left side of f of x. And this I would get by plugging into the less than 1 piece. All right, my thought process with this limit is x less than 1 corresponds to x approaches 1 on the left side. So here I'm plugging 1 into the top. We have 3 minus 1, and that's equal to 2. All right, so that's our left side limit. But our right side limit should give us the same thing. However, notice the right side is this piece, and a and b are constants. So you're going to get a times 1 squared plus b times 1. And that's just going to give you a plus b. So what this is telling you, for the function to be continuous, the limit as x approaches 1 has to exist. Okay, so what this means, like for f to be continuous, we need 2 to equal a plus b. Okay, so this is like we need f of x to be continuous. So that's why we're going to set 2 equal to a plus b. All right, if it's multiple choice, I'm just plugging in 1. I'm doing 3 minus 1 is 2. I'm plugging in 1. I'm getting a plus b. So 2 equals a plus b. But this is like the big result that you need. Okay, this is going to get it started. But now the next stage of this, I'm going to zoom out a little bit, and then we'll come back because I don't want to run out of real estate, is what we have is we find f prime of x. So we take the derivative of each piece one at a time. The derivative of 3 minus x is minus 1, x less than 1. And then the derivative of the bottom is going to give us 2ax plus b. Now on that old worksheet we said for now we set x just to be greater than 1 because technically not every value of a and b is going to make this true. There's only a certain value that'll make it true. So then what you have is you're going to have, like if I'm just doing this like for multiple choice now, I'm going to forget about notation. I'm just setting -1 equal to 2a1 plus b, which means -1 equals 2a plus b. So then now we have a system. So the rest of this is just algebra. So we could write the other equation right under it, 2 equals a plus b. And now just do the algebra. So I could say -1 equals 2a plus b. I could also say -2 equals -a minus b. And now when we do the algebra, we're just going to add these two together. And we're going to have -3 equals a because this is going to cancel. So since now we have a equals -3, if a is equal to -3, then 2 equals -3 plus b. So then b is equal to 5. So that's your unique combination. All right, but so at Richard, at hyperspeed, what I would do for a question like this, if it was multiple choice, is honestly like if I'm just getting this, if I want to just get this out fast, like at hyperspeed, I'm saying like, all right, 3 minus 1 equals a times 1 squared plus b times 1. Like I'm just plugging in 1 for x on top, bottom, and setting them equal. And then like maybe on the side, I would say, all right, the derivative f prime equals, and I'd have -1, 2ax plus b. And then same thing, -1 equals 2a times 1 plus b. You see, and then you have like, oh, I'm sorry, yeah, 3 minus 1. So you have 2 equals a plus b. -1 equals 2a plus b. System, solve. You know, like that's at live speed, how fast we're doing this. So, yeah. I hope that, Richard, that clears it up a bit, if that made sense. Hopefully. If you need me to go over it again, you know, for a different question, I can. But that's the idea. MVT with a table. Yes, absolutely. So I'm just going to make one up on the spot. Now, what you're going to get is you're going to probably get something like f of x is like differentiable. Okay, and it's like blah, blah, blah. Here's a table. Okay, so you get a table of values for x and f of x. All right, so this is at Dory. I'll do a two-part question. I'll do IVT and MVT all in one. So here, let's say I had 0, I don't know, 2, 3, and I'll just jump right to 6. So something like this, and then let's say it goes from like 3 to 5. Let me see where we're going to make this end. How about like 15? Yeah. And then this could be, I don't know, 7, let's say. So part A, it could be explain why. I don't know why I wrote the letter Y. Too much math. Explain the letter Y. No, explain why, the word Y. Explain why there must be a value C. So these are like I know, I mean, I can make these questions by hand by now. I've done so many of them. Explain why there must be a value c, where c in this case is between 0 and 6, such that I'll start with IVT. F of c equals, let's say 4. Okay, something like this. So my thinking right away, does actually 4, yeah, 4 works, whatever. My thinking right away is that we're going from a y value of 3 up to a y value of 15. So the function will reach 4 because on your way from 3 to 15, you have to pass through 4. Okay, that's the intermediate value theorem. But if I want to explain it and explain it well, I would the extra safe thing is that, you know, f of x is differentiable. I'm just going to abbreviate for the sake of time so I cover more ground. If f of x is differentiable, that means f of x is continuous. Okay, so that's the condition to use IVT, because the only way I could guarantee that I'm going to reach every height in between from one to the other is that I don't skip. Like I say, like, all right, I got to reach here. If I go like, haha, I skipped, then it's not continuous. Okay, so it's very important that your function is continuous so that it does pass through everything. So that's why I go the extra step to say that. So the next thing you have to say to apply the theorem is you should establish that the number that you're targeting for is between your two y values. So it's like, it's between these two here. So like this one and this one. So that's what I throw in next. Since the y value 4, so since the y value 4 is between 3 and 15, and I could say 3 and 15, I could also say like f of 0, and we make that neater. So f of 0 and f of 6. See how 4 is between the other two function values by the intermediate value theorem. Now we could say there exists, backwards c, to save time, a value c between 0 and 6 such that the function value at c is equal to 4. But remember, you could only use IVT once you establish that your function is continuous and that your y value is between the two given function values. Okay, and then there has to exist a point c between 0 and 6. At some point we have to pass through 4 on our way from 3 to 15, and that's going to happen between x equals 0 and x equals 6. All right, so that's IVT. Now MVT is very like close, except the question would look like this. It would say something like, explain why there must be a value, let's say I go with r, and r is between 0 and 6, such that, and we have f prime of r equals, and let me think. So let's say it's gonna be this. All right, so something like this. So to use the mean value theorem, we have to say the function is differentiable and continuous. All right, we already said that before. See, we said f of x is differentiable and continuous, but whatever, I'll write it again. So f is differentiable implies f is continuous. So now the mean value theorem applies. So how are we going to apply it? Well, now we could say by the mean value theorem, there exists a value r. R is between 0 and 6. And the way mean value theorem works, remember the phrase like mean is average. So when you apply the mean value theorem, you have to find the average rate of change. So it's like kind of built into the title. So by the mean value theorem, there's going to exist a point r between 0 and 6 such that we could say f prime of r is equal to the average rate of change, which is f of 6 minus f of 0 over 6 minus 0. Okay, so that's what we're saying here. Like this, the theorem guarantees it. And now when we simplify this, well, I got to make sure I remember the values here. So this means this equals f of 6 is 15 minus f of 0 is 3 over 6 minus 0. And this is going to give us 12 divided by 6. And check it out, it gives us 2. All right, that little symbol means you're done explaining, like you're done proving it. All right, now in case the mean value theorem doesn't make a ton of sense, because sometimes you're just like following a process and you're like, all right, if that's what they tell me to do. If we draw it out, not going to be drawn to scale necessarily. So like 0, 3. And then we're at like 2, 5. And now we're at 3, 7. And then we go out to like 6, 15. So like somewhere up here. All right, not drawn to scale, but whatever. So this thing looks something like this. So now what we just showed is that the slope here of the secant line, that's what we found over here. This is the average rate of change of f of x on the interval from 0 to 6. All right, like that's the slope of the secant line. So the theorem, as long as our curve is smooth and connected, then at some point, let's say here, the slope of the tangent line is going to be equal to the slope of the blue line. All right, so that's what mean value theorem guarantees us. So we're not actually finding it. We're just saying that it's like there exists a point where the slope of the tangent line equals 2, because the average rate of change from 0 to 6 is also equal to 2. All right, let's see. So, oh, is this when f prime of x equals the slope? Well, what we could say is that technically f prime is always telling you the slope of the tangent line. So that's a good thing to bring up. F prime of x is the slope of, so this is a massive idea for calculus. F prime of x is the slope of the tangent line. Okay, so like when we look at like just a random drawing, so if you got something like this, see, like if this is a graph of f of x, then like let's say this is at x equals 5, and the slope there is like, I don't know, like 1.5. Then in derivative language, we would say f prime of x equals 5 equals 1.5. And this means that the slope of, well, since the slope of the line tangent to f of x at x equals 5 is 1.5, that means f prime of 5 is 1.5. Okay? Oh, Bilal, hello, how you doing? So you had your first Calc 2 midterm. How was it? How'd you do? Or did you get the, what day is this? This is Wednesday. Oh, they might probably not graded it yet. But how was it? Did you find it to be okay, or was it crazy? So just glad you stopped by, Bilal. So yeah, for anyone from the current generation, Bilal is from last year's class. So if anyone has questions for Bilal, I'm kind of putting you on the spot, Bilal, but I'm sure you'd be happy to answer anything about what it's like to take the BC test. Had to ball or bail? Was it had to bail on them? You know what I'm saying? Okay. I don't know if I'm following 100. But what, was it a thumbs up, thumbs down, or you said you didn't take it? Maybe I'm just not following it right. But either way, I'll wait for your response. But I'm just happy you're here. Yes. So at Jada, MVT basically proves that there is some point where the slope of the tangent line equals the slope of the secant line. All right. Absolutely. So let me add another page here. So yeah, another way of thinking. Oh, it was easy. Nice. So that doesn't surprise me, Bilal. I know you're more than capable of handling a engineer type major. So stay strong. So MVT proves, yeah, that at some point the slope of the secant line, that's the line that connects A and B, secant line equals slope of tangent line. But the only way we can guarantee it is when our function is continuous and differentiable. Okay, that's the only time we can guarantee this. Oh, ball on them. Oh, it's slang for aced it. I'm sorry. You know, once you're, according to MTV, once you pass 25 years old, you're no longer relevant. You're officially old. So ball on them. I heard one of my students say, slide one, and I guess that meant like, can I have one? So yeah, I gotta catch up a bit. I don't know where everyone hears about. Yeah, but that's why once you're past 25, you're no longer cool. But it's all right. You all keep me cool, I guess. All right, so let's see. Tommy, can you go over fine points given the slope of the tangent line? Let me open up. Is that one of those? Let me see. Oh, all right. I'm worried about signing in right now because if I sign in to my work account, it might kick me off of integration by parts. But I'm trying to think. Tommy, maybe you could type in like a question in the chat. Finding points given the slope of a tangent line. Oh, Euler's method. Yeah, who was it last year? I think, Euler's method, I think we went over so many of those in the Saturday reviews. I bet you slayed it just fine. Yes, you got to have a nice advantage. The trig sub, that's something new. But let me think. What is that? I want to make sure I'm talking about the right thing, Tommy. So can you go find points given the slope of the tangent line? Let me see. I'm afraid of signing in and then it boots me out of this live stream. Like that would be... let me just try this. Moment of truth. Make sure it doesn't kick me out. Oh, there it goes. I am in. All right. And I am still on the live stream. Okay, so let me just look at... All right, I have to look it up just in case I don't want anyone's from the class's name to pop up on the live stream. That would be, I don't want to do that. Wait, hang on. I'll look one up and then modify it because I'm sure they have like copyright stuff too. So I want to respect their copyright wishes and I'll modify one. So I just got to look at the topic one more time. Find points given slope of tangent. All right. Given slope of a... Oh, okay. All right. So I'm going to just write out a question. Like if we have f of x equals x to the third minus 9x squared plus 20x minus 14. And we want to find all the points such that the tangent line has a slope of 5. So find points such that the line tangent, I'll abbreviate line tangent, has a slope of 5. Okay. So I will get out of this. All right. So when I read this, blah, 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 there's all this stuff. Find points such that really all I'm thinking about here, like at hyperspeed, is like, oh, set f prime of x equal to 5. So first order of business would just be finding f prime of x. And that's going to be 3x squared minus 18x plus 20. And then if you set it equal to 5, the rest is algebra. So you're doing 3x squared minus 18x plus 20 equals 5. And then we subtract 5 on both sides. We're going to have this. And now we're going to the mountaintop in our heads. So we got to know our 15 times tables. 3 times 15 is 45. The middle is negative 18. So we need a product of this and a sum of this, the factoring by the AC method. And the mystery numbers are negative 15 and negative 3. So then we take those numbers and we're here. And we've got 3x, x minus 5, minus 3 times x minus 5 equals 0. Now, this is going to make 3x minus 3 times x minus 5 equals 0. And this is going to make 3 times x minus 1, x minus 5 equals 0. So our two x values are 1 and 5. But then they said find the points x, y. So now we actually have the trouble of plugging back in. Oh, Ricky, hello. Kenny, hello. My old crew coming out to support. I'm glad you're all here. Welcome. It's really cool. I can't tell you, it makes me so happy like that last year and this year's students are here. Like it's like fusing the years together. That really is like to take a second to say like the coolest part of this job is like for sure like just being able to keep in touch with people and stuff like that. So thank you to the class of what year is this? 2022 for swinging on by. Yeah, the old crew. All right, I don't know what I just did. Did I actually paste this? I tried to paste it, and I think I failed. Let's try again. All right, there it is. All right, because I didn't feel like scrolling back and forth. All right, let's see. So now f of 1 equals 1 minus 9 plus 20 minus 14. I mean, a calculator's fine. If I say 5 plus 5 is 12, I apologize. Negative 8 plus 20, so this is like negative 8 plus 20 minus 14. These two make 6, so negative 8 plus 6, so it's going to be negative 2. It looks like. Let's double check this. 12. Yeah, that sounds right. And now f of 5, without a calculator, minus 9 times 25 plus 100 minus 14. I mean, whatever. I could go into old school math mode. So this is like 125 minus, that's going to make like 225. I'm going to write it this way because then it's just, this is going to make negative 100. So we have negative 100 plus 100, canceling, minus 14. I believe this makes minus 14. So your points should be 1, negative 2, and then 5, negative 14. But use a calculator. Like I hope I didn't mess up some of there. Scale factors for geometry. I do. Yes. So at Nino Nava, I do. So I could talk about scale factors. Sure. Let me pull up something. Scale factor map. All right. So let's see. Just to clarify, is it so at Nino Nava? Is it about like for triangles or like lines? I mean, whatever. I could just pull up line dilations. I mean, it could be. Oh yeah, because is it similar triangle scale factor or like? I guess it's all the same. Whatever. I'll just talk about scale factors. If I got to just pull up something random, I can. But it helps to have like actual questions. So let's see. What's a good one? I guess that works. I don't want to teach too much geometry, like meaning like it's early in the year. So like I don't want to start teaching you stuff you didn't learn yet. So at Nino Nava. So if it starts getting confusing, just like let me know. Because I don't want to go like too far ahead. Because I teach geometry this year, so I got to brush up on my geometry anyway, which is nice. I did miss teaching geometry. It's a really, I know sometimes it gets like a bad reputation, but I mean I like teaching geometry. All right, let me see. Ooh, this one looks. I want to find one that's good. All right, you know what? I'll just go here. 9. Let's see. This one here, something like this. So this, and I'll drag this down. Here's one. All right. So something like this. So line segment A. Oh, I actually need a graph. Ugh. All right. Sorry. Hang on. Do they have any? Oh, they have a blank graph. How convenient. Perfect. All right. So drawing it is good because geometry should be very visual. Geometry is all about like spatial awareness, angles between lines and figures and stuff. So line segment A prime B prime, whose endpoints are 4, -2. So 1, 2, 3, 4 down 2. So this is 4 and then -2. So that's A prime. And then B prime, oh, we ran out of space. So they do that sometimes because they don't want you to actually be able to graph it. That was kind of mean, but oh yeah, that's actually really mean. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if I extend this like 11, 12, 13, 14, 15, 16. So we'll cheat on this one. And then 11, 12, 13, 14. So like somewhere out here. So yeah, this is like really just meant to be crazy. So we have A prime, B prime extending way, 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 way out here like this. And is the image of A, B after a dilation of 1/2. All right, so they did this purposely because they don't want us to graph this. So the way a dilation works, let me like give some background notes. Is that a dilation, if we have like, let's say a figure, something like a triangle. Oh wow, it's like recognizing I'm trying to draw a triangle. So I'm just thinking out loud. And let's say I copy and paste this. So I just want to make sure we get the concept. So copy and then paste. Oh wow, it copied all of this. That was a fail. Hang on a sec. I apologize. Oh, those are all connected. That's devastating. So, you know what? I'm going to teach this separate and then I'll come back to this. All right, so I'll give a little background on it because I don't want to like teach too much like stuff and then it's like, what on earth are you talking about? All right, so triangle like this. And if we borrow this, here it is. All right, perfect. So these are the same, but let's say I like scale this up. So when I have like something simple, let's say this is actually a right triangle, like 3, 4, 5. And I have a scale factor of 2. And let's make that neat. A scale factor of 2. What that means is like everything is going to double in length. So 3 is going to go to 6. This side is going to go to 8. This side is going to go to 10. But one thing to know here is that a scale factor, let me just make sure I'm answering. Oh, so for ABC for triangles. Okay, for triangles is that the side lengths all grow proportionally. So when we have a scale factor, so I'll just say like scaling a figure increases distance proportionally. All right, I gotta look up like formal definitions and stuff. Proportionally. Spelling. Let's double check. Don't want to have mistakes here. Proportionally. Proportionately. Proportionally is a word. Sure, that's an adverb. Cool. Solid adverb usage. All right, so scaling a figure increases distance proportionally. So like that means like if this is 3, this is 6. Like this side doubled. And then this side doubled as well. And this side doubled as well. So when it comes to triangles, like that's what we mean when we say scale factor. If I had instead a scale factor of, let's say, k equals 1/2, then if I drew a new one out, let's say I do this one in blue. So if I have a new one, this would be 1.5, this would be 1/2, this would be 2, and this would be 2.5. But the angles are preserved. So scaling a figure increases distance proportionally, and we'll say angles are preserved. Okay, like when we shrink it down, it's keeping the angles between the lines the same. Okay, so this means like the triangles are similar, which means all angles are congruent. Now, one of the most epic bear traps when it comes to similar triangles. And this was on a from, if I don't know what state we're in, so at Nino Nava, but in New York we have Regents exams for geometry. And one thing that I remember one year this got everybody was, they said, like, let's say the area equals let's see, this one is like 6 square units. And they're like, what is the area of this triangle? So they're like, area equals, and like every kid whose paper I graded was like, oh, 12, because it doubles. But you have to be careful. So scaling a figure increases distance proportionally, but just know the area of a triangle is 1/2 base times height. So notice area is made up of 2 dimensions, the base and the height of a triangle. So if the base doubles, the height doubles as well. So the area should actually be not times 2, but it's k squared. So it would be actually times 4 in this case. So this would actually work out to 24 square units. But if we had to find it ourselves, we could use the formula 1/2 base times height. And the area of the second triangle is 1/2, and we have the base is 6 and the height is 8. And half of 48 does equal 24. All right, so just be careful. The bear trap with this, massive bear trap. And I don't know if your teacher is going to throw one of these at you, but just be ready for it. Is that the area is multiplied by k squared. Okay, so don't like just say, oh, the area of this area is 6, let me double it. Like, no, because the base and height are being doubled. So that means the area is being multiplied by 4 in this case. All right, if it was k equals 3, then the area would be multiplied by 9, because everything would triple. So the base and height triples means it multiplies by 9. All right, so that's a little piece of similar triangles, scaling triangles. Let's see. So next in the queue. All right, so I'm doing something different. Let's see. Yeah, you know what I'll say? If you all want, let me put an email address here. I have to organize this a little better. I don't know if I could just edit this. Let me edit the text. But at gmail.com. Okay, so if you want, like, if you have specific questions and there's like, it's like a lot to type, you could send it there, because sometimes like reading it from the chat, it's tricky. So doing something different. Mine is polygon, solve for triangle, solve for ABC, and it shows 3 numbers. Geometry 1 for high school. All right, so let me pull up that email. Just that way it's like more organized. I have to in the future ask people to send stuff ahead of time, because solving these questions on the fly is like fun practice for me. Live listeners, a hint of the test. Yeah, there'll be 20. So at Dory, I'll just say the mean value theorem with the table. I would say that if you study what I just put out there, like, it's not the question, but it's like a lot of solid stuff that'll help you do very well on that particular question. All right. So like the IVT, MVT stuff, it'll really give you, you know, like a leg up for sure. So the MVT, IVT I went to before, Richard, you as well. That system stuff, you know, definitely something, you know, to be mindful of. I'll see if I could rewind back at some point and add a little bit more about that table of value question. Like, what if you had to write the equation of a tangent line at a point? So yeah, but that, me putting that question out there. But I would say if you want to practice implicit questions, it wouldn't be a bad idea to open the AP Calculus Problems book, press Control Find implicit differentiation and do a few of the AP style implicit questions you run into. Just a thought. The answers are in the back. One of them has like a little typo. Oh, thank you, Bilal, for that. I had another request, so while I wait for the email, but let's see. Someone had requested, what was the name? Precalculus, rational root theorem to find rational zeros. Oh, that's really cool. That's like a fancy title that maybe I haven't run into. Rational root theorem. I just want to see what they mean by that, because, all right, let's see. Blah, 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 blah. Let's see. The theorem is used to find all rational roots of a polynomial. It gives a finite number of possible fractions which can be checked to see if they are roots. Written in lowest terms. Let me just see like practice questions on that, because sometimes it's like hard to just create questions on the spot. So I'm gonna see. That's very. I like that we're getting people from around the world, because this is giving me around the world, probably like still in the U.S. It's giving me ideas for like my own pre-calculus class. A factor of the last term a naught, a factor of the first term a sub n. Oh, this is interesting. So let's see this. A rational. So I'm gonna like kind of learn something, because he's like pre-calculus. I've taught pre-calculus for a while now. This is something that, yeah, I haven't run into this specific one. This is interesting though. Now, so a rational root. So at the whoever sent this comment, who wrote this comment? Rational root, blah blah blah. Rational root. Oh, differentiable functions. Yeah, I could explain that after. Yeah, through the email I have there would be great. So not a bot. Rational root theorem to find rational zeros. So yeah, you could send it on that email. So at not a bot. Rational root theorem. Let's see. So let me like write one out. They have something like this. So x to the third, let me make that neater, plus 7x squared minus 18x minus 8. So it targets the first and the last. So let's see, what's the idea? A sub n equals. I got to read up on it a little bit. This is an interesting question. It's very, very interesting. So they said they recommend only using this when the coefficients are small and as a last resort. It is less efficient than some other steps you could take first. Like first try factoring as much as possible. And it may turn out you don't need to use this method. You could use a polynomial of higher order, blah, 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 by reducing it to a combination of lower order equations. Oh, okay. All right. I have to just read up on this a little bit. It's an interesting topic. Let's see if I can learn this in live speed. All right. I'll give myself like a 5-minute time limit. So let's see. Oh, we have, I'm waiting for the email to, am I in the social? Maybe it's. All right. So I'll also wait for like a specific question in the email. But the theorem itself. So for anyone watching that has never heard of this, I'll be honest. I can't remember learning about this, but it's interesting. I mean, I'll try it out. A rational root of a polynomial. Function. Okay, and the function is f of x equals like a sub n x to the n. And then, all right, so this is like just the standard form of any polynomial degree n. So for the AP Calc people, like recognizing this general form is important for later. Okay, so this is just any. So a rational root of a polynomial is of the form P over Q, and they're saying this equals a factor of the last term a sub 0 or a naught over a factor of the first term a sub n. Okay, so it's a factor of the first term over a factor, a factor of the last term over a factor of the first term. Oh, there's a proof of this too. Multiply both sides by q to the n, subtracting this from both sides. Oh, that's a nice little proof. Let's see if they got examples. All right, let me just see. I'm waiting for the email. Waiting for that piece. I'm gonna just look up like a worksheet to see if they have like something in PDF form that I could just grab an example. Oh, they have it on CUDA software. All right, plus or minus 1 over plus or minus. Oh, all right. I think I see that the possible factors. So if this is all the theorem is saying, it's kind of like a silly theorem. It's not guaranteeing it either. It's just a possibility. So a factor of the last term over a factor of the first term. So if we had something like f of x equals 3x squared plus 2x plus 1. So I think if you take the first term and the last term, like the first term is 3 times 1. Those are the factors. 1 is equal to 1 times 1. So the possible factors is going to be a factor of the last term. So it's going to be 1, and it'll be like plus or minus 1 over, we could have either plus or minus 1 like this, which is going to give us plus or minus 1. Comma, you could also have a factor of the last term, which is still plus or minus 1 over plus or minus 3, which would give us plus or minus 1/3. So this is really all that's going on here. It's kind of like a silly example then. All right, I mean, I guess if that's what they want. So this just seems kind of painful. You're just like literally listing. I don't know if this is the kind of stuff you're looking at. I'll look at one that's like a little bit more complicated, because this one is like 2 prime numbers, but it only makes sense to do this if the numbers are small. That's why that was the tip, if it's relatively small, because this is like kind of silly. All right, I guess if that's the theorem they want, then great. I mean, it's more, what's more interesting about these little theorems is why they're true. So, I mean, we talked about that. I'll talk about something in a moment that kind of, not going too far off on a tangent. But here, like our last term is 10. And 10, we could call 10 times 1. It could be 5 times 2. And yeah, that's it. And then the first term, the coefficient is 1, is just 1 times 1. So the theorem says it's the factor of the last over a factor of the first. So this would be, if we start off with like, this one only has a factor of 1. So it's like plus or minus 1 over, and we could have like, let's say plus or minus 1, which would give us plus or minus 1. And then we could have, once again, it's a factor of the last term on top, factor of the first term on bottom. So the first term on bottom is giving us this, but now the other factor to try is like, let's say 2. So we could have plus or minus 2, and that would give us like plus or minus 2 here like this. And now the first term goes on bottom. So the first term factor is 1. And then we would move to like 5 next, like plus or minus 5. So this tells us like potential roots. I'm sorry, yeah, potential, rational zeros of this function here. And then the last one would be plus or minus 10 over plus or minus 1. So these are the potential values. Yeah, it's kind of like a silly theorem. I mean, it's nice. I mean, I want to like discount it altogether, but I would say like if you have technology, like you would Oh, all right. You sent it to the correct one now. Let me see. Yeah. So list all the possible rational zeros. Okay. So yeah, I'll take one of those. So let me just keep borrowing this theorem because that's what we're gonna need. So I'll do one of those, and then yeah, I will bounce back to the chat to answer any new questions. Okay. So let's see in that email. Let's say we look at x squared, x plus 1 minus 4. Oh, okay. So I'll just take a look at question 9. It's like if you have f of x equals x to the third plus x squared minus 4x minus 4. So the a sub 0, I'll just define it, is minus 4. And then a sub n is equal to 1. So that's the bottom and that's the top stuff. So this is like, you're going to have like 1 times 4, comma, like 2 times 2. And then, so the last term goes here. And the first term is just like 1 times 1 or negative 1 times 1. So it's like some combination here. So when I'm like, this is like how I'm thinking about this is if we use first, part A is list all the possible rational zeros. So it's going to be like plus or minus 4 over plus or minus 1, which is plus or minus 4. It'll be plus or minus 2 over plus or minus 1, which is 2. And then plus or minus 1 over plus or minus 1, which is 1. And now use synthetic division to test possible rational zeros and find an actual zero. All right, so synthetic division. So, oh wow, to test 6 of them, I would personally like want to divide this myself. Like I would, like I'll do one, I'll do this first and then I'll do the synthetic. But I would factor this by grouping. We'd have x squared times x plus 1. Take out a minus 4 and you have x plus 1 and set it equal to 0. So now you're going to have x plus 1 times x squared minus 4 equals 0. So you have x plus 1 times x plus 2, x minus 2 equals 0. So now you have x equals negative 1, x equals negative 2, x equals positive 2. And notice positive 2, oh yeah, plus or minus 2. So we have positive 2, which checks out with this. We have negative 2, which checks out with this. And we have negative, oh, I forgot to write the plus minus. We have negative 1. All right. So if we had done synthetic division, it would have taken us like, we would have went through 4 and negative 4 and had remainders, and it wouldn't have worked. All right. If you need practice with synthetic division, though, I could just, I'll write that over here in this little space. So that would be like, let's say, zoom back in. So we know now, we cheated, that 2 is an answer. So if a root is, one of the roots is 2, then we write the coefficients. We have 1, 1, negative 4, negative 4. And now synthetic, you bring this down as a 1, 2 times 1 is 2. And then you add, you get a 3, 2 times 3 is 6, 6 plus negative 4 is 2, and then 2 times 2 is 4, so you have no remainder. It goes in evenly. All right, and that was because 2 was a root. If I pick one of the non-roots, like let's say 4 wouldn't work. So we put 4 on the outside, and what do we have? We've got, oh yeah, it was 1, 1, negative 4, negative 4. This should give us a remainder. So if you're doing synthetic division here, bring down the 1. So we have this. This will make 5 when you add, and this will make 20. This will make 16 when you add, and this will make 64, giving you a remainder of 60. So it does not divide evenly, so it's not a root. Okay, if you have a remainder, that means this number out front is not a root. All right, so that's basically what they want you to do. I'm not going to do synthetic division 6 times. All right, that's kind of the idea. But then like I kind of cheated a bit by using factoring. That was the tip in that other site, that like obviously like the rational root theorem is nice. It tells you your potential roots, your potential rational roots. And yeah, these were part of our potential list. All right, it's a nice little theorem. I like that. Oh, Mary, wow, look at this. Oh, Marie, I'm sorry. Marie, how you doing? Nice to see you. So, wow, we're really getting a lot of The old crew. Oh, wow. Volume using disk and washer methods revolving around the x-axis. That is a nice topic. Let me see where we're at. Oh, wow. We had 82 people swing by. Very nice. We got 12 people on right now. So hello to everybody. So Jada, you said, could you explain differentiable functions? I understand the third grade concept, but the actual notation is a bit confusing. Okay. So differentiable functions. So there's this definition. So f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. So the way I think about this so that it makes sense, like, yeah, third grade language, we say if it's smooth, it's differentiable. But if I take this point here, this is the point, I'll call this f of x. So this is the point a comma f of a. So if I take like some random point here, call this x, then I'm going to like use not the most proper notation, but this is to illustrate an idea that this represents, so this part over here is the slope between a f of a and x f of x. So we say if this limit exists, so if this exists, if this limit exists, then f of x is differentiable at x equals a. All right, that's a big idea. Now, the thing is with this is the limit, remember we said that calculus is really like, you got to be like Ant-Man and the Wasp. So that's what we mean when we say x approaches a, is that like the distance between x and a is shrinking to Ant-Man and the Wasp level. So like I imagine this blue point is like moving way, 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 way closer to a. So like as x gets closer to a, this point gets closer to this point. So when we find the slope between them, like here's the tangent line, then the slope of the secant line, which is this one here, imagine like the purple line is going to like start turning so that the slope of that line matches the slope of the tangent line. Okay, so that's like at the like microscopic level, kind of like what's going on and what it means to be differentiable. Like when we say it's smooth, that means like that limit exists, that the slope as we're getting close on the right side and the left side is like matching the slope of the tangent line, that it's a smooth transition. Now, here's a function that doesn't work. If I said like g of x equals absolute value x. So this could be open to anybody, but where is absolute value x not differentiable? So where is absolute value x not differentiable? So we say here. So we just throw that one. I mean, I could just get to it, but spoiler alert. I don't know if there's like I think there's like a few second delay between like me talking and it popping up. But I mean, you're all getting it at live time. But yeah, it's 0. Very nice because of the sharp turn. So now let's say we were to say, all right, what is g prime of 0? Okay, g prime of 0 is the limit as x approaches 0 of g of x minus g of 0 over x minus 0. So now this would be the limit as x approaches 0 of absolute value x, that's g of x in this case, g of x is this, minus absolute value of 0 over x minus 0 is x. So I'm only like showing a million steps here. That you see how it's so easy to say like, oh, it's not differentiable at 0 because of sharp turn. So Jada, that's your third grade language. But if we were going to be really fancy about this and we use the definition with the limit, now you investigate this limit and you'd have to say something crazy like, all right, absolute value x is equal to x. If x is greater than or equal to 0, it's equal to minus x if x is less than 0. So then I'd have to break this limit into like two separate limits. I would say, all right, the limit as x approaches 0 on the right side, that corresponds to like 0 on the right is kind of like the same thing as x greater than or equal to 0. All right, like this is just an idea that helps. So then absolute value x would equal x. And x over x, this limit equals 1. But if I do the limit as x approaches 0 on the left side, the absolute value of x when x is less than 0, so 0 from the left is kind of like x less than 0, those match up, would give us negative x over x, because that's the definition of absolute value x equals negative 1. Or you could just see here, this is like the line y equals x, and this is the line y equals negative x. So y prime on the right is 1, and y prime on the left is negative 1. That's what this is telling us. So this implies together that the limit as x approaches 0 of absolute value x over x does not exist. And if that limit does not exist, that means g is not differentiable at x equals 0. All right, so that's like fancy notation. Can we go over the intermediate value theorem? Yes, I will say, so at June, if you rewind back, so this has been going on for what, an hour, 6 minutes, I would rewind back to like the 5-10 minute mark. I went through IVT and MVT already. So I'll say go into a time machine, go in the past about an hour. If it's still confusing, come back to the present and ask me. I went over it. I believe, Dory, that was your question before. So yeah, that is that one. All right, let's see. So other difficult linear approximation question. Yeah, I mean, we gotta see what we consider difficult here. Oh, 9:28. Wow, time flies when you're having fun. Let's look at that. But Marie, once again, hello. Yeah, I'm glad you're doing well. It's nice to see you. All right, let's see. Oh yeah, I could scroll back up to the MVT, IVT question. The answers will be there from before. Whoops. All right. Where was it? Oh, wow, we did so much math. Oh, here we are. So I'll erase, you know what, I'll write it up here. So let's say you had like an additional row. So f prime of x. And let's say, I don't know, we had like in this row that it's equal to 3. All right. So here, if I said, write the equation, so let's say part C. Write the equation of the tangent line to f of x at x equals 2. Well, then what you need here, you would say f prime of 2 is equal to 3. Let's fix that. That was not my best 3. All right, so f prime of 2 equals 3, and then you'd have f of 2 is equal to 5. Now, from this step here, you're using this formula, y minus y1 equals m times x minus x1. So then you'd have y minus 5 equals, the slope is the derivative, that's 3, times x minus 2. So y equals 3 times x minus 2 and then plus 5. Now, a question for, like, let's say part D would be to approximate the function at, like, let's say 2.1. So then what we'd have is f of 2.1 is roughly equal to, you plug into the line, and what you'd have is you'd have 3 times x minus 2. I'm sorry, we're plugging in, and my phone went off for a second, that's why I got distracted. That's why, yes, even cell phones for us yeah, are going to be distracting too, but I will get them later. All right, so 3 times x is 2.1. So this is going to give us 3 times 0.1 plus 5, and that's going to give us 5.3. And what that's telling us is that the approximate value at 2.1 is like 5.3, which makes sense because what we just did was we wrote the equation of the tangent line at x equals 5. And we saw here that, like, all right, it gave us 5.3. That's kind of close to like where we're supposed to be. So yeah, that's the idea for these. That it's not like perfect like the way we're able to see it here, but that's the idea behind those questions. Also at Marin Elise, yeah, the disc washer method. Yeah, so Dory, that question sort of similar to what you'll see at the test. All right, so yeah, there has to be some prize, right, for being here. It's like, oh no, I can't remember exactly what I put on the test, but I know what sort of kind of question I put on there. So that's sure that's fair to, like, it's not the exact question, but it's something similar to it. Oh, so cool. So at Marin Elise again, I don't know if you're still here, but are you currently learning disc washer, or are you like done learning it? Like, or you not learn it at all? Because I could show you one. I can make one up on the spot. It's kind of like my current students. It might, really be a lot to throw at you. So don't worry too much about it. But I want to make sure people are actually here. At Tommy, I would say sure. If you do all the optional Delta Math, why not? Extra credit. Because I know this class is hard. So sure, there should be a prize for doing all the optional stuff. Why not? I got to mess around too with the, which setting is it? Oh, it did. Oh, this is zoomed in like this. So I'll say, yeah, here, like, open Q&A for the last 10 minutes. I'll give, like, if you have like any math tip questions, because I'm probably going to rest with the, which questions? The, like solving math questions. I think I did go through quite a few. I'm just trying to see something here. Oh, wait, is this the only scene? Oh, no, here's the scene. This is like my Q&A scene. Oh, yeah, the fire. Yeah, I have a fireplace behind me. I'm really in my castle. No, I don't have a castle. I'm not that. Sadly, I'm not making that kind of loot yet. Let me just see. Pop out the chat. There's something I was like trying to learn how to do. So this is just like more behind the scenes stuff. But if we turn on the chat, let's just see. So I'm thinking out loud. Do this. And if I press the chat, give me one moment. Let me see if this is going to work. I hope it does. And is it working? It may or may not. Let's see. Oh, I should probably move this thing over. All right, this is better. Okay, there it is. All right, let's see. Let's see. Oh, we got it. Cool. So you got, I'm glad you're doing well again at Marie. So if anyone's got questions, I could do like open Q&A study tips. All right, so do we need to remember trig derivatives? Yeah, trig derivatives, yes. Inverse, I don't want to say no because I don't remember off the top of my head. But if I was ever going to ask you to know a trig inverse derivative, it would be sine inverse, which if I can know it, you could know it. The derivative of sine inverse is 1 over radical 1 minus x squared. Cosine inverse would be negative 1 over radical 1 minus x squared. And tangent inverse is 1 over 1 plus x squared. Those are the most basic ones to know. So those are fair game. Other questions, open Q&A, but nothing like I'm probably gonna not solve anything new. We'll say like 5-10 minutes of Q&A. So anyone who's still here, I don't know how many people we still have. So anyone else? Other questions? Does this oh, that removes it. Okay, sorry. There's so much behind the scenes to learning how to stream. How to not lose motivation. All right, so I'm guessing, Jada, you're taking a lot of like hard classes right now. I feel your pain. I really do. the most you could ever do is like just put in the time each day. All right. I mean, I know for my own students, I could say that you were all like massively ahead of where the average like student is at like the senior level. Like, you know, if you're taking like that many AP classes, like a future employer is gonna be like, we want to hire you like tomorrow, you know, like it's hard for you all to see it because you're like not at that stage yet. But I promise you, like I could say that about like just about everybody, that like you're all like on the right path and you're gonna make it. I know, like what's hardest about a class like this is you have all been like just stellar students like your whole life, and you still are. It's just now you're like entering the big leagues where like everyone in the top 10% of the school, like you enter a class like this, and then maybe it's not in this class, but like next year in college or the year after, and you're going to take a class where like everyone around you was top 10%, you know, depending on where you go. And then you'll be like, wait a minute, like now where do I stand? So it's like, it's a strange like time of like transformation where like you're kind of like going through like a like growth of some sort, but it's valuable. You're really gonna leave this class like knowing what it means to do well at the next level. You know, like it's tough for me because I could see you all making it through, but like you all have to actually get through, you know. So to not lose motivation, that's a tough one. I would say you just do what you've been doing all along. You stick to a schedule. You know, you give yourself time too to unwind. You know, like I know it may seem impossible, but you know, take some personal time to yourself. And look, like if you don't get like high 90s and hundreds on everything in math, like that's okay. You know, that's why I put my transcripts on the board. It's like the way our grading scheme is worked for AP classes, like you all still wind up doing like pretty well. But allow yourself like room to grow in a class like this. Okay. So just honestly, just do your best and like set the schedule and stick to it. And then if like you're feeling burned out, that's usually what causes people to lose motivation. You know, give yourself a little time to like unwind and relax, like is my best advice. So other questions on how, like, so we have how not to lose motivation. That's a great question because I need that too myself. Yeah, the teachers, like, you know, we also got to keep moving and stuff, and teacher burnout is a very real thing. But you know, I have like what I like about the school year is like I have like a very focused goal. Do I have any top favorite books? That's a good question. Let me think. What's the most recent thing that I've read? I mean, I'll read a variety of books. In terms of novels, if I pick the books that all of you had to read when you're in high school, I really enjoyed Fahrenheit 451. Just the concept of the book was really interesting. The Catcher in the Rye, maybe I shouldn't talk about Catcher in the Rye because those of you taking, you know, college writing are probably going to have to read that at some point, and I don't want to throw spoilers out there. But any book that really gets you to like evaluate your current situation and like your kind of like life philosophy is really interesting. Like I also read Flowers for Algernon. I thought that was like a really cool book. Of Mice and Men, just sad after Lenny. I just I was like Lenny, he's so cool. But Flowers for Algernon is another one too, because that whole concept of like, is it worth it to be like all about academics and like getting to that level, or are you better off like, I mean, not necessarily going the other extreme and just not learning anything, but like what's the prize? You know, it really gets you to like evaluate your values and stuff. So any book that like kind of confuses you, but not for like the wrong reasons, like it confuses you because it like gets you to think about yourself like in like a way that'll positively change your life, like I would say like those are pretty fun. Life of Pi was a really fun book. Without spoiling, I'll just say like Life of Pi like just had a very interesting plot. The movie I really didn't like too much. It was like kind of missed, not like it missed the point completely, but wow. Blake, I absolutely remember you. Bear traps was the joke. We joked about me getting bear a bear tattooed on my actual traps. So hello, I'm glad you're on. Of course I remember you. Yeah. So, and then you joined the wrestling team senior year, and you landed a takedown on Sebastian, the wrestling guy. And you're an actuary. Wow. That is like so awesome. No, I'm like just I ran into the twins in Barnes and Noble. They updated me. They told me you became an actuary. I appreciate you giving my AP Calc class some of the credit, but like your hard work is absolutely. So how many of those tests have you taken, Blake? The actuary exams. I know there's like I want to say like PM. That might be saying it wrong. And I gotta remember this is like chopping my head off. So let me fix this. Oh no, people are gonna see my actual background. That wouldn't be good. And let me do this. All right, that's better. Yeah, no one was. My bad. My green is a green screen behind me. My secret's out. I don't actually have a cool fireplace like this. Just took your 4th one. Wow. That's impressive. How was it? Was it insane? That is so cool. Yeah, so for anyone of my current students, Blake, what year did you graduate, Blake? Was it like 2017-ish or so? Was it 2017 or 2018? I think you were 2018, right? Did you graduate? I can't. The years kind of just blend together. That's how old I'm getting. Your year was like really like a cool year though. Nice group. You got sick a week before. I mean, I know you could retake those and stuff. But the 4th one, wow. So you're really aiming high and stuff. 2018. Okay, so cool. Yeah. So that was before my dad days. Like now, Blake, I have 2 little ones. So I have 2 kids now. The game has changed a bit. Oh, and Blake, I also have to give credit for anyone who plays video games out there. Blake, you got me to play Witcher 3. So you and Harvey told me that it was like Skyrim. It was like the OG Witcher, I think is how you referred to it. But I appreciate you all for turning me onto that game because I did have a lot of fun playing it. But I'm so glad you're doing well. That's like awesome news. I love to hear after you've graduated, like, and you'll come back and say hello that you're doing well. So play Elden Ring. All right, I gotta write that down. Do I need my PS4 just like burned out because like now my kids, I'm totally like convinced my kid like might have just slammed a toy truck into it and just broke it. So if I buy another PlayStation, like if I get a PS5, I'm gonna have to like encase it in like iron or something so that my kid can't get to it. Oh, okay. You and Harvey, hope Harvey's doing well also. Oh, for sure. You're always welcome. I know COVID made things complicated because like people weren't coming in. So, yeah, that's, oh, wow. Terraria. All right. So I'm getting all these game suggestions now. I got to write these down. So very cool. So let's see. Arthur von, Zubin, any tips for studying for GRE quantitative test, high school math level? Well, I want to say I haven't tutored specifically for the GRE, the graduate like entrance exam, or whatever that stands for. Again, I'm a little rusty, but honestly, like my whole process for getting ready for any test, like I used to teach SAT classes at my high school on Saturdays. This was in like my 2nd, 3rd year of teaching. I used to teach those. But the key to like getting skilled for like any test is like, for one, you got to do a lot of practice tests. And what is a detail that not a ton of people pay the most attention to is the timing. So something like, let's say the SAT, which is not the GRE, but for the SAT, you get almost, graduate record admissions. Awesome. But for something like the SAT, you got to do 20 questions in 25 minutes. So the theme is you have to move. So the math is like just math for the most part, unless we're talking about my former student Blake. Like an actuary exam is like sorcery level math. It's like something ridiculous. I'd have to probably take like a year and change, like just to study for like the first exam because I'd have to get like smart again with college math, and then that's like a statistics type math. So like if you've already learned the math, it's like the math you're preparing for, it's kind of like you're learning how to answer like that specific style of question. So by doing practice tests, you're just going to get familiar with it, but also time yourself. You really, really, really want to time yourself. So it's a combination, I always say, of doing practice tests to just do mixed practice. But then you got to see what questions are you getting wrong. And let's say you're always getting like, I don't know, like rational functions wrong. Then within those practice books, you do just rational functions. So practice shouldn't always be just practice everything. Sometimes you have to do specific target practice and work on specific topics that you need to work the most on. Right? Because some people, they just say, oh, I'm just going to do like 10 practice tests. And it's like, yeah, that'll help. But if you're not getting good at like one specific thing that you need to work on, then you're not going to really get the most out of your time. And I think of it like the same way, because I also train Brazilian Jiu-Jitsu outside of teaching. I haven't trained in a little while because like I've got like this it's kind of gross. I got like an eczema outbreak on my finger. So like if I train Jiu-Jitsu, I could get an infection. And I've had an infection once from like getting like bacteria in a cut, and it was just a nightmare. But when I do train, I sometimes we roll where we're just going for everything, but then otherwise we do specific training. Like, all right, start in this exact position and work on escaping or doing this. So it's like very specific goals in your training. So for something like the GRE, I would treat it the same way. Is I would work on the specific stuff you need help with and then do another practice test. So like do a practice test, see what you get wrong, work on like one or two specific things, do another practice test. Have a timer next to you. Oh, you're Brazilian. Look at that. What, like, that's a small world. Look at that. Yeah. I've been training Brazilian Jiu-Jitsu since 2010. I'm a black belt from like a Renzo Gracie affiliated school. So look at that. I didn't learn Portuguese, but it's a very interesting, little world that that community, and it's the sport is growing too. Their most recent massive competition, the ADCC event, was hosted at Las Vegas, so it's like finally like hitting like that next level in terms of like the fan turnout and stuff. So it's really gaining in popularity. Not saying that that's the only thing from Brazil, but like that's how I would say, like, I definitely met like a few guys from Brazil. Like Renzo himself is from Brazil. Some of the people who train there, but your GRE though, for sure, like time yourself on the practice test, and then after every practice test, pick one or two topics to really iron out and get the most use out of your time. Okay, because that's just a common thing. Like people just do like I said, 10 practice tests, and then like they don't really get the most out of it. So that's my best advice. Cool. So let's see, any other questions here. So let me see. I'm just gonna like resize this and see where are we on. Oh, here it is. Oh wow, we broke 111 views for the whole stream. That's exciting. It's growing. But Blake, I wish you the best of luck on your fourth one. I hope if it didn't go well, then I'm sure on the retake, if you have to retake it, that you'll be fine. How many tests are there in total? I don't know if you're still here, but I vaguely remember there being like 7-ish actuary tests, and if you pass them all, you're like a millionaire. So I forget what the story is with that. But like the tests get like really insane at the end. But that's so cool that you're on to the fourth one. But let's see. 950. I'm going to have to cut out soon. I do have to. Company pays for those exams anyway. Very nice. Very nice. So let me just see. Is this still popping up here? Very nice. I'm glad that you're. There's 10 if you want to make 500K. So yeah, that one's definitely worth highlighting here. Very cool. If you want to, making 500K would be pretty nice. I wouldn't mind that. I'm someone to say, hey, we're going to pay you that much. But all right, sure. I'm glad you enjoyed. Thank you. So thank you all for, so at Boris, also, I'm glad you stopped by. So thank you all. But I'm going to probably cap it at this. But once again, thank you all for swinging by. And I'm so glad, once again, we had people from even as far back as class of 2018 to now the class of 2023. So I really, I'm so happy, like, just getting that many of you for like to be on this too, like the old crew supporting everything. Thank you so much. And for the new crew, good luck tomorrow. I wish you all the best. So take care. Let me just see